Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is templated functions. Before proceeding, make sure that you have already watched these other videos first. When you write an ordinary function and then build your code, compilation will happen to your function definition, and a bunch of executable code will be generated at that location in the software. But when you write a template of a function, no compilation happens at that place. Instead, for any specialization of the template, it gets compiled at the point in time during software building where you first use the template that way. Notice how the specialization type is written within angle brackets. We like to always specify it for clarity, but you could omit it if it could be unambiguously inferred from parameter types. A single template can be specialized in as many different ways as you want. Each will use the same generic implementation. You could specify an exception to this. Here, every specialization of this increased template will use the same generic implementation, except a specialization of T as a short. That specialization will use its own special programming. Although a template is not compiled where you write it, that template code does need to have been seen by the compiler by the time that you specialize it. So there are a few ways you could organize your files. One option is to write your template definition in its own dedicated source file. At the end of that dedicated source file, you write this declaration that triggers specialization of it. That causes compilation, with the compiled result going into your dedicated module. Client code and other source files can use that specialization, the same way that they use any ordinary function exported by other source files. For the convenience of those clients, you often put a declaration that they can use in a header file that they can include. This approach assumes that you can correctly predict ahead of time which specializations will be needed. Some libraries, like STL, put both declaration and definition of the templated function into a header-only file. Clients only include that header-only file if they plan on specializing the template themselves. If you take that approach of putting the full implementation of a template into a header-only file, and you are using it for multiple pieces of client code, then unfortunately, your template gets redundantly re-specialized and recompiled in each of your clients. C++ now has this special directive. You put it in all but one of your client source files, which causes them to borrow the specialization from somewhere else.